Hi class, in this video we're going to be talking more about the dplyr verbs, going into detail and going through some code together. So first of all, I set some options. I loaded the libraries I needed. I set my theme to minimal because it's my favorite. I've loaded the Palmer Penguins data and my garden data. Let's jump into select. So select chooses which variables to keep. We'll start with the example you saw in the intro video. We'll select the variables vegetable and weight from the garden harvest data. So I have my data set already there, garden harvest, and I'll use the Control-Shift-M to insert the pipe, and then select vegetable and weight. I love the autofill. And if I run that code, I see that now I only have vegetable and weight. Notice that this does not affect my original garden harvest data, which is still over here with 421 observations and 5 variables. We can select a range of consecutive variables using the colon. So here, if I take my garden harvest data and then select from vegetable through, that's what the colon means, weight, I'll now get 4 variables. I don't get units, which was the last variable. There's also helper functions we can use. So I'll give an example of starts with. I'll take the garden harvest data and then select all the variables that start with V. This is sort of a silly example, but it can be useful in certain situations. So notice it returns vegetable and variety. There's many other cool things you can do, and I have a reference in this document. Moving on to mutate. Mutate adds one or more variables. So I'm going to redo the example that we saw in the previous video. So I'll take the garden harvest data, and then I will create 2 new variables. The first new variable we'll call weight pounds, and that is going to equal the weight times this number that I have right here that I'm going to copy and paste so I don't make a mistake. And then I'm going to create another variable called over 1 pound, which will be a true or false, a true if that harvest was over 1 pound. And in this, I'm going to use weight pounds, the variable I just created. So if weight pounds is greater than 1. This is logical, so it's essentially asking the question, is the weight bigger than 1? If so, it returns a true, otherwise a false. One other thing I want to point out here is that when you give things names, start with a letter, keep it all lowercase, and if you want to sort of separate words, separate them with underscores. So if I run this code, we can see that the new variables are added to the end of the data set. We see the weight in pounds, and then this indicator variable. So at first there's a lot of falses. Eventually I have some bigger harvests, and they show up here. Another type of mutate I use, or actually I haven't used it a lot yet because it's pretty brand new, is across. So we can combine across with mutate to apply the same transformation to multiple variables. So here, I'm going to change all the character variables to factors, which are a special type of character variable. So just looking up here, we see that, back over here, vegetable, variety, and units are all character variables. So I'm going to mutate. So across all the variables where they are they are characters, that does not have parentheses, I'm going to convert those ones. So across all the variables that are characters. I'm going to convert those to factors. All right. So now we see vegetable, variety, and units are all factors instead of characters. Again, there's a link to more details about mutate. Moving on to filter. Filter keeps cases that meet certain criteria. And we often, pretty much always, are going to use some sort of logical operators when we're filtering. Here's a list of them. So from the first video, or from the previous video, I forgot to include in our code chunk. So let me do Command Option I, which is the shortcut for a new R code chunk. Let's take the garden harvest data and then filter to tomato and cucumber cases where the harvest date was on or after August 10th. So first we'll do vegetable is in. And let me just point out a couple of things here. When I'm going to make a list of things, I start it with this function C, which you can think of as concatenate or column. Okay, anytime I'm going to give a sort of a list of things, specifically a vector, I need to put it inside of C. And because this is a character variable, I need to enclose these values in quotes. So tomatoes or cucumber. So that's my first filter. And I separate my filters with a comma. The second one is that the date is bigger than or equal to, and here I'm going to use a function from the lubridate library, YMD, which I can give a date in the format of year, month, day. So 2020, 0810. I can actually give this date in a lot of different formats, but we'll stick with that. And if we look through here, we would see that all of these are on or after the 10th, and it's only tomatoes and cucumbers. Okay, another useful filtering function is drop NA. So used by itself with no arguments, it'll get rid of any cases that have missing values in any variable. So for example, here, if I use drop NA, let's actually first look at the penguins data. This has 344 observations. When I use drop NA, notice that this now has 333. So it's dropped 11 observations with missing values. Now, if I put in a variable specifically, so let's say I do this bill length millimeters, now it's only going to drop the rows where bill length millimeters is missing. So here it only dropped 2 rows. So clearly there's other variables that have missing values. Okay, and a link for filtering. Moving on to arrange. Arrange reorders the cases according to a specified criteria. So again, doing the example from the video, we start with the garden harvest data and then arrange cases in alphabetical order by vegetable. Then within each vegetable, the cases are arranged in descending order of weight. So from the heaviest to the lightest. So here, first I arrange by vegetable, then I arrange by weight, but I want them in descending order. It automatically does them in ascending. So I can use this DSC function. And there we see the vegetables arranged within each vegetable from largest to smallest. I made pesto these 2 days. Okay. It's important to note that these arranged changes do not actually change the variables, so they don't pass through to plotting. So in the following code, I arranged the vegetables by heaviest to lightest harvests. Don't worry about all this code. We'll go over some of this later, but let's look at the output. So here we see tomatoes are first, zucchini, cucumber, and so on. So if I try let's just try piping this in to ggplot. And I'm gonna put total harvest on the x-axis, and on the y-axis, I'm going to put vegetable. Oops. And what did I forget? I told you I make this mistake a lot. I forgot to tell it what geom to plot. So notice it has not arranged this. So this arrange does not pass through to plotting. In order to arrange this, we actually have to reorder vegetable. So I showed you in a previous video, factor reorder vegetable by total harvest. I think I'm missing a parenthesis there, and let's put this on a new line to make it look better. And there we have it. Okay. Moving on to summarize. Summarize creates new summarized variables, or variable, I guess. This function is almost always used along with group by. Before moving on to that, I want to point out a couple other functions that help you count. Counting is a very common thing, especially when you're brand new to a data set. One is the function n, which can be used inside summarize. So if I take the garden harvest data and then summarize it, and maybe I'll call this variable count and use that function n, it doesn't take any arguments. It just counts the cases or rows. So here, it simply counts the rows. Now, I could also add a couple other things like I did in the first video. So I think I computed the average weight. So mean weight and the standard deviation of weight. Okay, so n is a convenient function to use. If we only want to count, we can also use the count function. So here, count, this is just a shortcut of this code that I had up here. The other cool thing is if I put a variable or variables in here, it will count by those variables. So kind of a shortcut for group by. So, oops, I guess I left a space to do that down here. So if I count by vegetable, I'll actually see how many times each vegetable showed up. Okay, now moving on to group by. So using group by alone, group by creates a grouped variable. Using it alone doesn't really visually seem to do a lot. So if I add a group by here, oops, and run this code, nothing markedly changes in my output. But if I run this code here in my console, oops, typo, garden, we see that this is now I didn't actually group it by anything, so let me go back and change that. Let's group by date, like I said to do. No wonder it wasn't doing anything. And let me go back down here. And let me actually group by date. Oops. There we go. Now we see that that the groups are date, and there are 66, which means that there's 66 unique dates, unique or distinct dates. Okay, now what do I have us doing? Okay. Let's find the total harvest by vegetable and date. So I'm going to group by both vegetable and date. And we want to summarize, and we'll call this total harvest. And this is going to be the sum of the weight. Okay, so if I go through here, I can see how much I harvested of each vegetable on each date. Okay, for many of these, I only harvest one per day, so this hasn't done a whole lot, but sometimes, like with lettuce, I might pick it multiple times a day and have multiple recordings per day. Now I want to find the cumulative harvest by vegetable and date. I'm going to use a mutate right after the summarize. And I just want to show you, I'm going to copy and paste that code so I don't have to rewrite it all. And I'm going to pipe right into a mutate, and I'm going to compute the cumulative harvest as the cum sum of the total harvest. So here we have the total harvest for that day next to the cumulative harvest. And what I want to point out is that when we did this, it is still grouped by vegetable. Okay, so for example, we see that the cumulative harvest for basil starts at 5, which it was on the first day. It's not 25. It hasn't carried over the harvest from the asparagus. In this case, that's actually what we want, but we need to be careful about that. If our next step doesn't use the group data, this could lead to an incorrect computation. We can ungroup the data using the ungroup function. So let me go ahead and copy and paste the code down here. So when I'm done with the group data, I can ungroup. I don't need to put any arguments in here. It's just going to get rid of all the grouping I have. And now, actually, it might be more helpful to run this in the console just so you can see that when I do this, there is no more grouping. Okay. We can also use group by with other functions after it. Summarize is the most common, but it's useful in other places. So for example, I might want to add a variable that is the average daily harvest for each vegetable. I can do that by using mutate after group by. So again, I'm going to group by vegetable and date, and then we'll mutate and add a variable called average daily harvest. And this is going to be the mean weight. Okay. And the new variable is towards the end. So what I want to show you here, let me just do a real quick trick here. I'm going to select average daily harvest and then put all my other variables so that I can see that at the beginning. So we can see that this amount is different for the different vegetables, which we expect. And it's actually different by vegetable, by date. Okay. Actually, maybe what we want to do instead is just do it by vegetable. That might make more sense in this case. There we go. So now we have the same average for each vegetable. Okay, we can also use group by with filter. So we could keep all the cases where the weight is greater than the average harvest weight. So let's, oops. So, whoops. If this ever happens to you, I pressed Control-Shift-N, which creates a new document, instead of Control-Shift-M. I make that mistake all the time. So I'm going to group by harvest, or excuse me, I'm going to group by vegetable. And then we're going to filter, and we are going to keep the ones where the weight is larger than the average harvest, so then the average weight for that vegetable. Okay, so let's maybe, oh, I guess one way to see, so it's gotten rid of 100, or excuse me, we only have 165 rows left, and there were 421 to begin with. So it's clearly done some filtering, and we could go investigate if it's doing it correctly, but we'll just trust that for now. Okay. And here's a link to more summarized information. Well, the last thing I want to do is go through a couple of examples. So from the previous video, I showed you how we can build up code sequentially via pipes. Here's the example from that video where we've plotted the cumulative harvest for peas and tomatoes. Many of you can probably already look at this code and understand it. For some of you, that part is still hard, and that's totally okay. But what is even harder is starting with a question or goal and figuring out how to get the answer. And we're going to do that together right now. So our new example, I'm interested in learning how many days have I harvested each vegetable and how that relates to how much I have harvested of each vegetable. I have purposefully not worked through this before this video, so I can show you what my stream of thought coding looks like. Oh, 2, and by 2, I mean 3 things I want you to watch are building up code. I start with small bits of code and talk through it. I do this even when I'm not recording myself, ask my kids. And I run small sections of code. As I build up the code, I run what I've done so far to make sure the outcome is as I suspect. Don't wait until the end to run your code. And lastly, I flare up the plot at the end. So when I finally get the plot I want, that's when I spend time on the details, labels, themes, fonts, color palette, etc. Okay, so let's think about this question. How many days have I harvested each vegetable, and how much have I harvested each vegetable? Okay, so first things first, I'm starting with the garden harvest data, and then I'm going to do something to it. So I need to compute some things. So to me, the first thing I'm actually going to do, because I know that I have some vegetables that have been measured more than once on a day. So like lettuce, for example, if I harvest it at lunch and at dinner, that would be 2 measurements on the same day. So the first thing I'm going to do is for each vegetable and date, I'm going to summarize that data, and I'm going to get, what am I going to get? I'm going to get the daily harvest, which is going to be the sum of the weight. So let's call this daily harvest G for grams. And I'm going to run that code. This is typically what I do. So I see I have vegetable, date, and how many grams I harvested. So, yes, the other thing I'm remembering my own data as I talk. So for things like tomatoes, I have a whole bunch of varieties of tomatoes, and usually I harvest a whole bunch of different varieties. In the original data set, those each have a row. In this data set, it's just tomatoes in general, okay? So this only has 291 rows, while the original data set had 421. Okay, so that seems to make some sense. Okay, now I want to know for each vegetable. So anytime I find myself saying for each something, that tells me I'm going to want to group by that. So then I'm going to group by vegetable. And I think I want to know two things. I want to know how many different days I harvested that vegetable. Well, if this is what the data set looks like now, that's just counting the number of rows. So that's the n function. So I'm going to call this number of days, number days. And that's just going to be n. And then the other thing I want to know is how much total, right? Yes, how much I harvested. So let's do total harvest, and let's make it total harvest in pounds because, well, my brain is used to thinking in pounds. Some of you might be more used to grams or kilograms or something like that. So let's see here. So I want to sum the daily harvest in grams, and then I want to multiply that by, I need to go back up here. Here we go. There's that number I need to translate it to pounds. Okay, and I'm going to run that. So now I have even fewer rows. I only have 26 rows, a row for each vegetable. Okay, so now what I might do is I just kind of want to play around with this a little bit. So I'm going to try arranging this by number of days. And let's do that in descending order. So what have I harvested the most? That's what I thought it would be. I harvest lettuce almost every day. Okay. So how might I sort of visually display this? Okay, right now what I'm thinking, I'll just keep that arrange in there even though I'm gonna have to do a little something else. Right now what I'm thinking is on my x-axis, I'm gonna put number days. On my y-axis, I'm gonna put vegetable. And I'm actually going to make a geom point. Okay, so now these aren't in order. So now I'd like to order these points from biggest to smallest. So I'm going to use that trick again, where we use factor reorder vegetable by number of days. And let's see if, okay. So that's the number of days I harvested. The other thing I'm gonna add is I'm gonna, oops, not there. I'm gonna add another aesthetic that we haven't seen yet. And that is a size aesthetic. And I'm gonna size these by total harvest pounds. Let's go ahead and look at that. So now I'm starting to see some things like, you know, this dot is sort of small but I harvest that thing a lot. Well, lettuce is really light, so that's probably why that is. Okay, so I think I'm sort of good with this plot. And now at this point comes the sort of fun part. So this is where I'm going to try to clean things up. So the easiest thing I find to do first is the labels. So let me make a title. And let's call this let's see, days harvested. Let's make it a question. How many days was each vegetable harvested? And I don't think I need a y-axis label because it's pretty clear what these are. So I'm just going to leave that empty. And let's see. Because number of days is in the title, I also don't think I need an x-axis label. So I'm going to go ahead and leave that blank as well. And let's see how that looks. So that looks a little bit better. The other thing I want to do is let's make a new label for the size. So I can do that by putting size down here, and I'm going to call this harvest weight in pounds. Oops. Okay. The other thing I want to do is I want to move this to the bottom. So this is one I almost always have to look up, and I'm going to cheat and look over here. So we can modify our theme, and that's where this legend piece comes in. So one of the things I can change are legend position, and I'm going to move that to the bottom. And I'm going to run this code again, see how it looks. Okay, that's looking better. There's probably quite a few things I'd want to change. I'd want to sort of change the plot layout a bit here. This looks a bit squished. I'd sort of want to stretch that out a little bit. Just looking at the, I'm going to skip that for now and just show you a couple of other sort of cute things we can change in the theme. So one is the background color. Usually I'm okay with white. Some people like to change this to, let's say, a darker color. I'm going to change it to this color called Snow 1. And the other thing we can change is the font of our text. So I changed that to Times New Roman. Okay, so this is just giving you a sense of how you can customize your plots and be pretty creative. I encourage you to do this as you go on, and not only do I encourage you, sometimes I'll make you do that. So I really do hope you have fun with that piece of it. Okay, that concludes our talk about dplyr verbs.